Okay, everyone. Before I start the lecture, any of you have any questions? Everything's crystal clear? Any questions about the homework assignments, quizzes, exams? Anything? Yes?
Do you anticipate maybe grading me again within the weekend?
I'm going to do it today.
Okay.
Yeah. So hopefully I can manage to just post the grades by today. I wanted to do it before our class today, but I was grading my other class, and like yourself, they had 6 different versions, so it took me a while to write all their solutions and grade them. So hopefully I can manage to do it today. Any other questions? Thank you for asking. Okay, if not, what I'm going to do is that I'm going to, continue with chapter 7, and also I'm going to start chapter 8. And the reason I'm doing that is that I want you, most of you have the lab, and I want you to be prepared for the lab, not hearing the materials for the first time in the lab. And last semester we weren't consistent teach, the lectures and the lab, so students would go to the lab, they would hear the concepts for the first time, and they would struggle. So I want all of you to succeed in your lab also, as well as the class, and also don't have difficulty, and instead of being there 3 or 4 hours to run an experiment, you just be there for like 1 hour and a half or 2 hours, if you can just get it done sooner than later. So that's why I'm going to start chapter 8 today, and hopefully I teach you all the materials today and Monday for your labs. Okay? But I specify which part of the chapter I'm teaching in case you are reading the book, you know which sections to study. Any questions? Okay. So can anyone tell me what is a chemical reaction? And in order for us to be faster, I need your participation so we have can go through the slides quicker. Anyone? Yes?
The transformation of one or more substances into different substances.
Exactly. So if I tell you, is the following statement true or false? This is a chemical reaction.
False.
Exactly. This is not a chemical reaction because water in liquid form converts to water in gas. So it's still water. You should have different substances. And can anyone name some evidence of chemical reactions? Yeah, I've been here too, right? Just participate so we can progress.
Color change?
Yes.
Emission of light?
Exactly. Light emission, yes.
Gas formation.
Gas formation, excellent. What else?
Solid formation.
Solid formation, yes. What else? Heat absorption, great. What else?
Emission of heat?
Exactly. So these are like some evidence of chemical reactions. Know those for your exam. And chemical equation. As I said, chemical equation is the way that we represent chemical reactions. So when we look at a chemical equation, we know what substance reacts with what substance and what are being produced, what are the states of the reactants and products. So if you have a solution, what we put in the chemical equation. Can you tell me, sitting in the back? So if you have a solution, what state do we put in parentheses in front of the reactants if you have a solution?
Liquid? Aqueous?
Exactly, right? And if I give you a chemical equation, you should be able to identify what are the states, And here I gave you that, so it's straightforward. All of them are in gas phase. And I may give you this as true or false. I say in the following chemical reaction, liquid water is being produced. So that is false, right? Liquid in gas phase in this specific reaction is being produced. But what is wrong with this equation as we wrote here, as it is? What is wrong with it? Yes?
It's not.
Exactly, it's not balanced. I have, 2 plus 1, 3 oxygen here, I have 2 oxygen here. And this is contradictory with law of conservation of mass. So I'm going to give you this in the exam. I say, what law has been contradicted? It would be law of conservation of mass, because matter is not created nor destroyed, right? So you should have the same number of oxygen atoms on the, what did I write here? On the left side that you have on the right side. And the same with other elements. So if I write, CH4 plus O2 gives NaOH. What is wrong with this equation? So one thing is like the number of oxygen atoms and then sodium atoms on both sides. So the number of atoms is one issue, but what is other issue?
There's a different element.
Exactly, so I don't have sodium on my reactant. So how would I have sodium on right side, right? You should have the same element, and the number of atoms in each element should be the same. Any questions so far? Good? Right? Here, I listed here for you. So if you have a solution, you have aqueous solution, and we write that with AQ. And if you have gas, we put G, right? Gas, right? Liquid, solid. So, okay. And we talked about how to balance chemical equations. For the purpose of our course, as long as you hold on to the element that is by itself, hold on to that and balance it the last, you can answer the questions that I asked you, okay? And the other thing, good thing about multiple choice questions is that even if you don't know how to balance a chemical equation, you can count the number of atoms in reactant side and product side, so you can technically answer the question in exam, even if you don't know how to balance a chemical equation. And I'm going to give you separate questions, so I don't give you a reaction description and ask you to write the balanced chemical equation and solve a numerical question, because if you don't know how to balance chemical reactions, I don't want to also lose points for other types of questions. Does that make sense? So for your exam, you should be able to answer the question regarding balancing chemical equations, because you can just count. If I give you this, plus 3O2 gives CO2 plus 2H2O. And I say, is the following reaction balanced? Yes or no? So you count, even if you don't know how to balance chemical equation. You count, number of oxygens here is 6. Number of oxygens here is, 2 multiplied by 1, right? Remember coefficients, we also consider those. Plus 1 multiplied by 2, right? And even if you don't put parentheses, you know that first you should multiply, then add. But you can also put parentheses to be safe. And then that would be 4. So you say the number of oxygens in both sides is not equal, so this reaction is not balanced. Okay? Good? Are we good? Where was it? So we also talked about different types of reactions. We had precipitation reactions in which a solid is being formed upon mixing two aqueous solutions. So you have like aqueous plus aqueous, and that produces something solid, or precipitate as we call it. Good? This slide. We also have acid-base reactions. Acids, what did they contain that I told you to remember? Hydrogen. They have hydrogen in their formula, like HCl, like HBr, like H2S, like HF, or like HNO3, right? So they have hydrogen in their chemical formula. What about a base? They have OH, right? For instance, MgOH2, NaOH. So these are acids, these are bases. Okay? Good? You're following me? So if we mix them, this hydrogen reacts with this OH and it produces water. And this NO3 and this Na, they will form an ionic compound, right? And we call that a salt. So a reaction that forms water and typically a salt upon mixing of an acid and a base. Are we good? So if you see something that has H, something that has OH, they produce H2O, water, that would be an acid-base reaction. And also gas evolution reaction, these produce gas. So that should be fairly straightforward, right? Any questions? Are we good? The previous they had, and also we had oxidation reduction reactions that we said these reactions are reactions in which electrons are being transferred, okay, from one element to the other. And also now I'm adding this session that we have and we call these oxidation reduction reactions redox. So this is like reduction, this is oxidation to be more precise. Instead of saying, oxidation reduction, we say redox. So being more concise. And we have 3 different types of this. The general definition is when electrons are being transferred. But specifically for you to identify them, you have 3 different rules. The first one is that if you have a substance that reacts with elemental oxygen, okay? And as we said, all combustion reactions are also oxidation reduction reactions because you have a substance that reacts with, elemental oxygen, okay? Or a metal reacts with a non-metal. If you have a metal, for instance, iron, reacting with oxygen, and then it gives you iron oxide. This would be, metal plus reacting with a non-metal. So that would be also oxidation reduction reaction. And more generally, one substance transfers electrons to another substance. So here you have combustion reactions, right? That in the next slide I'm going to talk about. But these are also oxidation reduction reactions, or if you have metal reacting with a non-metal, okay? That also be oxidation reduction reactions. Any questions so far? Are we good? Go back to the chain here. So here you also have Fe plus O2 gives iron oxide, right? But that is not combustion because when you have piece of iron somewhere that is, that rusts, right? And then it oxidizes, you don't see any heat. So combustion reactions are reactions in which that you see heat being generated. So that's the difference. So I just copied and pasted an example from your book that says which of these are redox reactions. Let me just cover this for now. So what about the first one? Is this a redox reaction? Why? Exactly. A metal is reacting with a non-metal. What about this one? What is this one? What type of compound it is that I just mentioned previous slide? Acid, right? Exactly. What about this one? It's a base, right? It has an OH, and this is hydrogen. So what type of reaction is this one? Exactly, acid-base reaction. What about the other one, which is CaS plus Cl2 gas gives CaCl2S. What type of reaction is this one? Do we have any gas? You should, in gas evolution reactions, gas is being produced, okay? Don't get tricked, here you have gases, yes, but gas is not being produced. Any other ideas? So we don't have any gas. Do we have any acid or base? So it's not gas evolution reaction, it's not an acid-base reaction. Do we have oxygen that something, burns with, or we have combustion reaction. Is it combustion? No, right? So what type of reaction is this one?
Precipitation.
Precipitation. So you may see solid here and get tempted to say that this is precipitation. But remember, in precipitation you have two aqueous solutions, right? That you mix together and then you get a solid. So you don't have two aqueous here that mix together. So what is this one? What type of reaction is remaining? Redox, right? You have metal reacting with a non-metal, right? So this would be a redox reaction. What about the last one? Can you see that? Zn solid plus Fe2 plus gives Zn2 plus Fe. Here you have your Fe has Fe2 plus is an Fe atom, iron atom that has lost 2 electrons, right? Can you see that? So now here, this Zn, loses the 2 electrons and give it to Fe. And Fe gains those 2 electrons, and now, it doesn't have positive charge anymore. So we're dealing with electrons being transferred. What's that?
Redox.
Redox, right? So when you see the transfer of electrons, that would be a redox reaction. Does that make sense to everyone? So here are also the answers. Are we good with all the examples? Do you want me to explain more? Any of them? Good? No? Okay, if we're good, I also have combustion reactions, as we said. In combustion reactions, you have a substance that reacts with elemental oxygen, right? And produces oxygen containing species, and a species means one kind or sort of thing. So instead of writing element or molecule or ionic compound, I refer to all of them as a species. But you should have a substance that has oxygen plus heat. So to distinguish whether it's like combustion or not, you see like oxygen containing a species plus heat. Okay, any questions so far? Good. If not, let's try to distinguish these type of reactions. I give you, tell me which one of the following is which type of reaction, or at least like 3 gas evolution reactions, 1 acid base, and I say which one of the following is acid base, or like which one of the following is combustion. So let's look at the first one. What do you see? So what is this compound? Acid, exactly. What is this one? And what do you see as product? Right, so what type of reaction is this one? Okay, great. What about this one? Acid, right? And you see water, so again would be acid-base reaction. What about this one? Okay, 2 aqueous, yes. But you see acid, but do you see a base? No, we don't see a base. But what do we see? Gas, right? So this would be gas evolution reaction. Are you following me how I'm doing this? What about this one? Exactly, it's redox or oxidation reduction reaction. Okay. What about this one? So these two reactions are like more familiar because we encounter them in daily life. You know, probably most of you have like something metal that is rusted, or like, you know, some of you may use like, you know, ovens or stoves that they use methane, right? So these are like kind of probably would be more familiar. So what is this reaction? We have something reacts with oxygen and produces oxygen containing species. So this is combustion, yes, combustion. But remember that all combustion reactions are also redox reactions. Okay? The other way is not correct. We may have like a redox reaction that is not combustion reaction. Okay? But all combustion reactions are redox reactions. Any questions so far? Yes?
How do you know whether it would produce heat or not?
I'll give you that in the exam.
Okay.
Great question. Any other questions? Okay. If not, let's practice some more. Okay, so what type of reaction is this one? I guess I just included that in the previous one too, right? What is it? It is redox and it's also combustion. What about this one? Precipitation. We see a solid upon mixing two aqueous solutions. So this is precipitation. What about this one? We have solid upon mixing two aqueous solutions. So this is also precipitation. Any questions? How I identify these things? Okay, now balancing chemical equations. I told you what is balancing chemical equations, right? And the way that we practically do it, we only change coefficients. And I cannot emphasize enough. We don't change subscripts, because if you put like change, you know, H2O to H3O, this is not water. So we don't do this, okay? We only change coefficients. So now let's look at this equation that I wrote here. How should I balance this? Or what should I do the last? Exactly, the ones that are by themselves, the elemental, the elements that are by themselves, we do them the last. And in this case, I take care of H2 the last. And I start with aluminum. And your book says that when you have metals, you tend to do them in the beginning. So if you have like O2, H2, N2, those guys, you take care of them the last, you know. But probably in this case, even if you start, even if you do aluminum the last, probably you get the same result. So you don't have to worry too much about it. Any questions? Good? Okay. So how many aluminums do I have in the right of the equation? So what should I put here? 2. Can I write Al2? No, right? Because we don't have diatomic metals, right? We have elemental metals, okay? It's kind of like if I put like O2, I have like oxygen, O2 in the air, and I change it to, like I say, okay, I have O3. So O3 is ozone, it's not O2 anymore, right? So remember, don't change subscripts, just change the coefficients. And one thing to remember, at this point, you should be able to identify polyatomic atoms. So I give you the table in the exam, but you should be able to write the name of the compound. So here, can you tell me, I had a professor in college that he would call on us and then say, the person that is not looking at me or think that I'm not talking to them. So you, yes, can you see me? So third row from the behind. on this side, the person behind you, the person in front of you. So the person between those two, yes, yeah. Can you name this compound? So do you guys have the table of polyatomic ions in front of you? Or can anyone tell me what is? So first of all, what are the cations and anions in this compound? Can anyone tell me that? Yes, aluminum, but what is its charge? 3+. So this one you should remember. And let me switch to this. Okay. Okay, don't want the light. So here, so your compound was Al2SO4 3. Okay. Al4 or like Al4 3 2 Al2 SO4 3. Okay, so now having this table, can you tell me the name of this compound? Yes? Aluminum. So you have, yes, exactly. So can anyone see that? Let me go back here and I write this for you. So you have SO4 2- as sulfate, right? And you should know that Al exists as 3+. And when you write this name, you write aluminum sulfate. And we said for polyatomic ions, we don't change it to IDE. We just write the name of the polyatomic ion. And why didn't I write 3 here?
Doesn't have an ambiguous charge.
Exactly, just like one type of charge. So when it has one type of charge, we don't specify it. But if it was manganese or iron or chromium or anything else that has multiple charges, we should also specify that, right? Aluminum. And you should be able to identify that this consists of Al3+ and SO4 2-. Any questions? Good? Okay, now that we kind of refreshed our memory about this, let me have this as a clean structure. What you do when you want to balance chemical equations, you consider your whole sulfate or polyatomic ions as one unit. So you don't balance sulfur separately and oxygen separately because that makes your life really difficult. Okay? So what you do here, first we started with aluminum, so I put 2 here, so now that is balanced. Now we go look at SO4. Okay? So how many SO4 I have on the left? 1, right? What about in the right? 3. How can I make this SO4 3? Putting a coefficient here that is 3, right? Now I have 3 SO4 on the left, 3 on the right. Good? So now how many hydrogen do I have on the left? 6, right? How many should I have here? So how many already I have? So what should be the coefficient here? 3, right? 3 multiplied by 2 would be 6. And now that is balanced as well. Are we good with this example? Yes.
Let's clarify that whenever there exists a diatomic element, you do that first, even if there's, say, aluminum out on its own.
We do these guys last.
Oh, sorry.
Yeah,
last.
exactly.
Okay.
Any other questions? Are we good with this? If with this, let's go through this example. So I start with Fe. Fe is 1 on both sides, right? So how many chlorine I have on the right side? How can I make this one 3? Coefficient of 3, right? Because 3 multiplied by 1 would be 3 Cl. Now, how many hydrogen do I have on the left side? So here, I have 2. What coefficient should I put here for that to become 3? I divide this number 3 by these 2 here, right? Does that make sense? So if I put 3 over 2 here, 3 over 2 multiplied by 2 would be 3. So I get what I want. But like chemical formulas that we don't want to have any decimals, we don't want to have any ratios, we don't want to have ratios here either. So what we do, we multiply everything by 2, the denominator here, to get rid of the ratio. So what we write is 2Fe solid plus 6HCl aqueous gives 2FeCl3 aqueous plus 3H2 gas. And we multiply all the coefficients, like 1, 3, 1. Here we have 3 over 2. We multiply all of them by 2, because when you have an equation and you multiply it by something, you should multiply all the constituents, right? All parts of that equation. Any questions? Good? Okay, and I have 2 more examples here, or 1 rather, yeah. 1 more example that I encourage you to look at it at home, try to balance it, email me, or like come to my office hours or go to your SI pass if you have any questions about that, okay? Now, if you don't have any questions, I'm going to start chapter 8 and talking about calculations in chemical equations and chemical reactions in general. And your book has this analogy of baking pancakes with chemical reactions. And you can think of it as any recipe for that matter. When you're making something, or like baking pancakes in that case, I mean, don't try this at home. Maybe it doesn't give you like good results. I don't know, is it like accurate? Actually, you should have like 1 cup of flour, like 2 eggs, you know. Probably this is like accurate, but it didn't list the liquid ingredients, so just kind of like to demonstrate the point. If you have like 1 cup of flour, 2 eggs, half a teaspoon baking powder, that gives you 5 pancakes, right? So if I, tell you now I have 4 eggs, okay? I want to make more for, I don't know, tomorrow too. I want to make, I want to make more pancakes and I have 4 eggs. How many cups of flour should I have? 2, right? Or if I tell you that I want to make 10 pancakes instead of 5, I have company. And how many cups of flour should I have? 2. You see that, you automatically did that in your head, and that is basically, where did I put this? Okay, that is basically the conversion factors that most of you are afraid of. You just like did that in your head. But what you did is that you said, I told you that I want to have like 10 pancakes. How many cups of flour should I have? And what you did in your head was that you said, how many cups of flour equals 10 pancakes? And you wrote a conversion factor that converted pancakes to cups of flour, or like cup of flour, doesn't matter much for our purpose. And you said that for 1 cup of flour, you can bake 5 pancakes. So now these two canceled out, and the result was 10/5, which is 2 cups of flour. Does that make sense? Are we good with this example? So this is the same as chemical reactions. So what happens in chemical reaction is that these recipes, in the sense, these a specific amount of each ingredient that you have is your balance.
Sit down. Do you ever go to seizures at all?
2 years ago.
2 years ago? Okay. So you're epileptic then?
I hold my hands.
Okay, so let's get someone to call 911, by the way, guys.
No, you don't. I just need it.
Okay. Let's call her because that wasn't right. So basically, yeah, that was like a secret. Like you just had it. You feel like you still feel like when you
Everyone's doing well? Yeah, I just notified Deb. So she said she'll call 911.
Sorry.
No worries. And don't be sorry. Okay, everybody's fine? Huh. Okay, any questions? Okay. So I was out of the class, so not. So going back to flour or whatever I was talking about, these ingredients give you a relationship between the reactants and products. Okay, so this is the same story when we have chemical reactions. And that is what I told you, that if you know chapter 6, you know chapter 8 basically. Previously you had chemical formula that would give relationship between your elements. For instance, in one CO2 molecule, you have one, or in 1 mole of CO2 molecule, you have 1 mole of carbon, 2 moles of oxygen. Now this is the same story here, but with chemical reaction.
I did call.
Okay.
And help us out the way.
Okay.
Where's the student?
So the student left the class, went outside. Yes. Thank you.
Do we know what it meant?
I think it was-
Yeah, they were like right out there.
Okay.
Thank you. So here we have 2 moles of sodium. Yeah, sometimes if we just like go to the student, it just like stresses them out. So it's better to just leave them alone and then they help, actual people that can help them. So 2 moles of sodium reacts with 1 mole of Cl2, generates 2 moles of NaCl. So the coefficients in a balanced chemical equation gives us, or like give us, information about moles. Okay, 2 moles of sodium plus 1 mole of chlorine gives 2 moles of NaCl. If you can identify this, the rest is like what we learned before. So here it says how many moles of NaCl result. You write a question mark. Moles of NaCl results from complete reaction of 3.4 moles of Cl2. We just write what we want to solve, and we multiply that by a conversion factor that converts mole to mole. Remember, this is the same as before. We don't convert gram to gram. We convert grams to moles, moles to moles, moles to gram. So moles of Cl2 cancels out with moles of Cl2, and we write moles of NaCl. Okay? And for 1, or what is this ratio? Can anyone tell me?
Or 2/1?
So 2, exactly. We have 2 moles of NaCl for 1 mole of Cl2. And when you just multiply this by that, would be 6.8 moles of NaCl. Okay? And now, if we have masses, the procedure would be the same, but you have 2 more steps, converting grams to moles by molar mass and converting moles to grams, again, by molar mass. Okay? So here it says how many grams of glucose. So you say how many grams of glucose, which is C6H12O6, can be synthesized from 58.5 grams of CO2. So first you write what you want to solve, and you convert grams of CO2 to moles of CO2, because we always convert moles to moles. Okay? And we convert moles of CO2 to moles of C6H12O6. Can anyone tell me how I can do that, or what is this ratio based on this? 1 exactly to 6, right? For 1 mole of C6H12O6, I have 6 moles of CO2. And also, now I get rid of moles of CO2. Now, what about moles of C6H12O6, 2 grams of C6H12O6? How can I write these 2 conversion factors? Molar mass, right? So do you remember how to do that for CO2? Right? So you say you have 1 carbon plus 2 oxygen, and you substitute these numbers and you write this number, right? Grams per mole. And you do the same for C6H12O6, and then for hydrogen you have 1.01, so you write C multiplied by 6 plus H multiplied by 12 plus O multiplied by 6, and then you substitute 12.01, 1.01, and 16, and this is example 8.2 that I wrote here. When I write the final answer, it would be 1.80.2 grams per mole. So for 1 mole of CO2, you have 44.01. 1 mole of C6H12O6 has like 180.2, and your final answer would be 39.9 grams of C6H12O6. Let's go to the attendance so you can be done with it. And we solve more problems next session.